On day 59, students will begin the culminating project for the unit. This project ends the extreme living unit, giving students an opportunity to synthesize all of their learning through all 5 unit tasks, plus the initial liftoff task. The culminating project consists of 2 parts, a group presentation and an individual report. The group presentation is more or less a continuation of task 5. Groups have designed, prototyped, and tested their ideas for a product that will maximize or minimize thermal energy transfer. They have also had a chance to see each other's prototypes and experimental results, and then make revisions to their own products, incorporating what they saw from other groups. Now, each group will present a final version of their product, with a complete explanation. The components of the group project are given in the slides for day 59, as well as in the Student Culminating Project Expectations Google Doc. This doc begins with the description of the culminating project, the purpose for the unit. Remember, students saw this back at the beginning of the unit, so it shouldn't be anything new. They've also revisited this project at the end of every unit task in the reflection or evaluate phase, making connections between the task that they were working on and this culminating project. Be sure to review the project criteria with the students and clarify any questions that groups have. The first criterion, a description of the selected region, aligns to the liftoff task, as well as tasks 1 and 2, in which the students selected an extreme climate region, then learned how the unequal heating of the Earth's surface, as well as oceanic and atmospheric circulation patterns, caused that region's extreme climate. Remind students to return to the work in their project organizers, as well as the student handouts from each task, in order to find the information they recorded for each criterion. Students should not need to do any new or additional research in order to fulfill this part of the project. They've already investigated it throughout the unit. The labeled diagram, or physical prototype, comes straight from task 5, which students just completed. For an explanation of how the product works, students should return to tasks 4 and 5. Remember, in task 4, students design an experiment to learn more about temperature change, applying concepts of thermal energy transfer, as well as temperature and kinetic energy of particles. Students may have many options for the presentation itself, but it should be visual, organized logically, and interesting to the audience. Students can decide their roles themselves, as well as how to split up the work fairly, but Day 59 also provides suggestions for how to do so. One group member might build a final prototype or draw a final design diagram, while other group members assemble the required information or actually design the presentation. The actual design of the presentation is very open-ended. Each group will submit only one presentation, but there are many possibilities when it comes to format. They could just submit a written report with visuals or even a Google Slides presentation that organizes the information more visually into sections. If students want to get more creative, they could create a physical or digital poster or even a video to explain and demonstrate their product. Students might have fun making it into an advertisement rather than just a straight factual presentation. Encourage them to be creative in how they present their final products. When students have created their presentations, they will present to the class synchronously or asynchronously as they're able to. If students are in person and able to present synchronously, one student should represent the group to present their work. If your students are working remotely, asynchronously, or if you prefer to give students time to explore each other's work independently, then students can post their presentations on a platform that allows their classmates to view their work and comment. Padlet, Flipgrid, or even just the question assignment in Google Classroom are all possibilities for students to view each other's work and leave feedback. When viewing each other's work, students should also do some peer assessment and give feedback using Rubric 8. This rubric asks students to consider how well each group has explained the scientific principles that form the basis for the products they have designed. How does the product actually maximize or minimize thermal energy transfer? The teacher's guide to the unit, as well as the slides for day 60, provide some helpful look-fors with the rubric. For example, to tell if a group's work scores at the proficient level, look to see if the diagram actually shows a product that minimizes or maximizes thermal energy transfer. Also look for writing in paragraphs, captions, or labels that explain the scientific principles at work in the product, specifically how thermal energy transfers from hot to cold, and how thermal energy relates to the movement of particles. Although it may be missing some detail, Most of these key points should be in the presentation in order for it to be rated as proficient. Those are the key criteria for creating and assessing the group project, part 1 of the unit Culminating Project. The group project has a few criteria and is assessed with only one rubric, whereas the individual project must hit multiple criteria and can be assessed with up to 7 other rubrics. The difference is one of detail and depth. And the individual project will give you a more truly accurate assessment of an individual student's understanding of the key concepts from the unit. Students will write a consumer report that goes into great detail about the product their group designed. Students will define the problem the product addresses, explaining the origin of the problem through a discussion of the climate where their product would be used. Why is it difficult to live there? What criteria are necessary and constraints make a solution difficult? Remember, these project criteria were also addressed in the liftoff task for the unit. To give a detailed description of the climate in that region, students should turn back to tasks 1, 2, and 3. In those tasks, students learned about how the unequal heating of the Earth's surface causes different climate regions to form, as well as how atmospheric and oceanic circulation affect those climate regions further. They also learned about the cycling of water throughout the Earth and then made connections to their chosen climate region. In their consumer report, students should also cite specific quantitative evidence to show patterns in data that allowed them to figure out the cause and effect relationships in these climate factors. For a description of the design process, students should look back to Task 5, when they engaged with the design process in order to create their prototypes. Task 5 and the previous group project will also provide them with the labeled diagram of their product and an explanation of how it works. The pros and cons come from their work with their group, as well as their analysis of and feedback on other groups' products. Again, none of the criteria for this project are really new. Everything comes directly from the tasks that students have already completed. If this connection is made clear to students as well, it will likely help them with any anxiety that might come from completing such a large summative task. The system of rubrics for the Culminating Project can also seem daunting, but only because there are so many. Another video with the slides for day 61 addresses these rubrics in detail, connecting each one to a task from the unit and explaining how they are three-dimensional. You can assess students on all or some of these rubrics, and even have students assess each other or themselves. Whereas the group project could be in a variety of formats, the individual project is primarily a written report. However, students should also include various diagrams, especially a diagram of their product. They can also include diagrams and models to demonstrate their knowledge of Earth's climate systems and how they contribute to the extreme climates and extreme living that they have studied over the course of this whole unit.